There's a status code in the web's plumbing that has been sitting unused for about 30 years. 402. Payment required. Someone reserved it in the early 90s for a future where the web could charge for things directly. And then that future did not arrive, because there was no way to move a tenth of a cent without the fee costing more than the payment. That code is now live. Software can be handed a budget and told to go and buy what it needs. No account, no subscription, no card details. It just pays, per request, and gets on with the job. Which is genuinely useful. And it means that, for the first time, the thing spending your money is not you. Today, how that actually works, how big it really is, and what happens when the thing holding the wallet can be talked into things. Two things before we start. This is not a hype video, and it is not a doom video. The technology here is real, and I think parts of it are genuinely good. I am also going to show you numbers that do not match the story being told about it. Both of those can be true. And nothing here is a recommendation. No protocol, no product, no token. Educational content, not financial advice. If you have watched the earlier lessons, this one sits directly on top of Lesson 6, and it breaks the rule we ended that lesson with. I will show you exactly where. Start with the mechanism, because it is simpler than it sounds. Your agent asks a service for something. The service replies, 402, payment required, and it attaches the price and where to send it. The agent signs a payment, asks again, with the proof attached, and this time gets the data. 4 messages. That is the whole protocol. The reason this never worked before is arithmetic. A tenth of a cent cannot travel over card rails. The processing fee is many times the payment. Stablecoins changed that because sending a very small amount costs a very small amount. So what X402 actually is an old idea that finally became affordable. And what that unlocks is worth understanding, because it is not just a cheaper checkout. It removes the account. Think about how software buys things today. Somebody signs up, agrees to terms, gets an API key, sets up billing, and manages a subscription, whether or not it gets used. All of that exists to answer one question: who is this, and will they pay? If the payment travels with the request, that question answers itself. An agent can use a service it has never heard of once for a fraction of a cent and never return. Neither side needs to know who the other is. That is a real change in how software can be composed. It is the part I find genuinely interesting. It is also not one thing, and that matters if you are trying to work out where this goes. X402 is the crypto-native one. Stablecoins, settled on chains with cheap, fast finality, built into the HTTP request itself. Google's AP2 is the broader one. Announced in late 2025 with dozens of launch partners and over 100 organizations soon after, including the card networks. It works across both cards and stablecoins, and it is built on signed mandates. One for what you intended, one for what is in the cart, one authorizing the payment, each cryptographically signed. Then there are the card scheme's own versions, Mastercard Agent Pay, Visa Trusted Agent, which are narrower and which can sit underneath AP2 as the funding method. Here is the tell about where the industry thinks this is going. Mastercard confirmed in early 2026 that it participates in all of the major protocols. Not one. All of them. So if someone tells you they know which standard wins, they are guessing. The people building it are hedging. Now the numbers. And this is where you should sit up. The reported figures are impressive. By late April 2026, 69,000 active agents, 165 million transactions, around $50 million of cumulative volume. The wider ecosystem has been valued somewhere near $7 billion. Then you look at what is actually settling on chain, roughly $28,000 a day. And independent analysis suggests that about half of the observed transactions are not real commerce at all. They are what the analysts politely call gamified activity. Automated, self-referential, often driven by incentive programs that reward transaction counts. Let me be fair about what that means. Infrastructure built ahead of demand is not automatically a scam. Every payment network in history was mostly empty at the start, and someone has to build the rails before the traffic exists. But there is a difference between a network that is early and a network that is busy, and the charts will happily blur the two. Transaction counts are the easiest number in the world to manufacture. Volume that somebody actually paid for is much harder. So when you see a headline about agentic payments exploding, ask which number it is quoting. Now the part this lesson exists for. 6 lessons of this series come down to roughly one instruction. Slow down and verify through a channel the other side does not control. Hang up and call back. Check the address independently. Ask the question they cannot script an answer to. An agent does none of that. Not because it is badly built, because that is the entire point of an agent. It reads what it is given, it decides, and it acts at machine speed without you. So what happens when what it reads contains instructions? This is called prompt injection. And it is not exotic. A web page, a document, an email, a product review, a calendar invite, anything the agent takes in as content can also contain text addressed to the agent. There is no reliable line between data and instruction, because to a language model, it is all just text. The security community's assessment in 2026 is blunt. OWASP puts prompt injection at the center of agentic risk, and the harder conclusion emerging from that work is that it may not be a bug that gets patched. It may be a permanent property of building systems this way. And notice what changed as soon as those systems got a wallet. The failure used to be embarrassing. You tricked a chatbot into saying something stupid. Now the failure is a transfer. There is a second route in, and it is one people rarely picture. You do not have to fool the agent if you can get in underneath it. In March 2026, 2 backdoored versions of a widely used library were published to the main Python package repository. They were live for around 3 hours. In that window, they were downloaded roughly 47,000 times. The library was not obscure. It is the gateway that a number of well-known agent frameworks route their model calls through. The way in is the part worth remembering. The attackers did not break the library. They got a publishing token through a compromised, continuous integration setup at a security company and used it to push signed, legitimate-looking releases. And the payload was itself an autonomous bot. Once it landed, it did not wait for instructions. So the attack surface around a paying agent is not just the prompt. It is every dependency in the stack, and every build pipeline those dependencies pass through. Your agent's wallet is only as isolated as the least careful package it loaded this morning. So what do you actually do? None of this is a reason to avoid the technology. It is a reason to give it boundaries. Give it a float, not an account. A separate wallet with a small working balance, topped up deliberately. This is Lesson 2's hot and cold split, applied to software. The agent gets the spending money, never the savings. Set the limit per task, not per month. A monthly cap sounds prudent and is nearly useless. An agent that has been hijacked will spend the entire month's budget in about 4 seconds. What actually contains the damage is a ceiling on a single job, and a ceiling per transaction. Use an allow list. The agent may pay these endpoints. Not any endpoint it happens to read about. Most injection attacks need the money to go somewhere new, and an allow list ends that conversation. Put a human in front of anything unusual, a threshold above which it asks. New recipient, larger amount, unfamiliar service, approve it yourself, and log every payment somewhere the agent cannot write to. If it does go wrong, the difference between a bad afternoon and a genuine mess is whether you can reconstruct what happened. One habit underneath all of that: treat anything your agent reads as untrusted input. Web pages, documents, emails, search results. That is not paranoia. It is the same assumption every other kind of software has made about user input for 30 years. Agents are just the first systems where we forgot to. One open question, and I would rather name it than pretend it is settled. When your agent pays a stranger because a web page told it to, who is responsible? On card rails, there is an answer. Decades of chargeback rules, dispute processes, liability shifts between banks and merchants. The framework is boring, and it works. And it exists because those systems have been getting this wrong for 50 years and slowly building the rules. A stablecoin payment made by an autonomous agent has none of that. The transfer is final. There is no dispute counter. and the legal question of whether an instruction produced by your software from text written by somebody else counts as your authorization. That is genuinely unsettled, which is not a reason to stay away. It is a reason to size your exposure to a number you could shrug at until the rules catch up with the technology. One sentence to take with you: an agent that can pay is a piece of software that can be talked into things. That is not cynicism about the technology. Everything in this lesson follows from it. Why you give it a float instead of an account. Why the limit belongs on the task. Why everything it reads is untrusted input. And it is the honest end of this series. For 6 lessons, the advice was, slow down and verify it yourself. This is the first time the thing spending your money cannot do either. So the care has to move somewhere else, out of the moment of the decision and into the limits you set beforehand. That is the whole job now. Not watching every payment. Deciding in advance how much damage a bad one is allowed to do. Thanks for watching. Look after each other out there.